Dear student, this is our topic, namely the electric field. What is electric field? Electric field, it is a space around a charged particle where it experiences its electric force. It is an imaginary surface around any charged particle, whether this charged particle is positive or a negative. Your electric field, it is of a four type. One is known as uniform electric field. Another one is known as a non-uniform electric field. And third one is known as variable electric field. And fourth one is a constant electric field. So what is uniform electric field? In a uniform electric field, its strength everywhere where it exists, it is same, uniform. If we have a unit positive charge, then this unit positive charge experience a equal force everywhere. In non-uniform electric field, a unit positive charge experience a different electric force at a different point. What in electric variable electric force, its magnitude again it change or vary at a different location in a electric field. What in a constant electric field, its magnitude, it is independent of time. Whatever its value exists at a particular instant, it always exists in all time. So it is a constant electric field. Our next one topic is electric field intensity. Electric field intensity. This electric field intensity, it is also called as electric field strength, and it is a vector quantity. It is designated with the words E having vector above, and in mathematically we can write this E as this one, F upon Q naught. F is a Coulomb force which exists in between two charged particles. Here are the two charged particles. One is this one, Q, positive. Another one is this Q naught, a very small one. It is a test charged particle. Distance in between them, suppose it is a small r, then we know that a Coulomb force F which exists in between these two charged particles, F has a magnitude Q naught 4 pi epsilon naught into r square. So when we put the value of this F in this equation, in the equation E, then this E further can be written as this one. So its value is Q naught 4 pi epsilon naught r square into Q naught into unit vectors. Here this unit vector is showing the directions of electric field strength, and it is radially outward, pointing in this way. And when Q naught cancel with this Q, so its value, it is equal to Q unit vectors 4 pi epsilon naught r square. As we know that unit vectors r, it can be written as vectors r over its magnitude. So value of electric field intensity in terms of unit vectors, further it can be rewritten as E, it is equal to Q 4 pi epsilon naught r square vectors r into r vectors magnitude. So it can be summed as q vectors r divided by 4 pi epsilon naught into q. So this is the expressions for electric field strength. In a simple term, we can also write it as, without vector notations, we can write it as this one also sometime 4 pi epsilon naught r square, which shows that this E, it is directly proportional to the magnitude of your source charge, whereas it is inversely proportional to the square of distance in between them. This electric field intensity, it has a unit Newton per coulomb, and its dimensional formula can also be derived in this way by its definition. By its definitions, we can write it as E is equal to F upon Q naught. Since F has dimensional formula ml t minus 2, Q naught, which it can be written as I into t. So its dimensional formula E, it is equal to m l t minus 3. I means current. Current has a dimensional formula A, ampere. When it went in numerator, it become inverse. So this is a dimensional formula. Next, our topic is to find out electric field strength due to a electric field strength due to a point charge. This is a point charge. So point charge value, it resembles with the definitions of electric field strength itself. Suppose this is our source charge lie at the origins of coordinate axis. This is our coordinate axis x, y, and z. Let small q is magnitude. Let a test charge q naught lie at a point P from origin O at a distance small r. So we know by the definition the value of electric field strength. It can be written as Q 4 pi epsilon naught into r square into a unit vectors. In terms of vectors, this unit vector, it is radially outward, pointing in these directions, showing the direction of electric field intensity or the strength. This unit vectors, we know it has value vectors r over its magnitude, but vectors r can be written as I x plus j y plus k z, and its magnitude r vectors can be written as x square plus y square plus z square under root. So when we put both value in this equation first, then value of E can be taken as equal to Q 4 pi epsilon naught I x plus j y plus k z divided by x square plus y square plus z square raised to power 3 by 2. In terms of its Cartesian coordinate system, we can write value of electric field Ex as equal to Qx upon 4 pi epsilon naught x square plus y square plus z square 3 by 2, because if can be E can be written as I Ex plus J E by plus K Ez, and after comparing the component, their corresponding component, its value is this one. Okay,